Hi, it's Dave. Welcome. Today I'm joined by James Douma. He is a frequent guest on my channel. We talk about Tesla FSD, Tesla AI, all things neural nets. Welcome, James, back on the show. How have you been?
Great to see you again.
Yeah, it's
It's
been
been a
good.
while.
Yeah, it has. I was thinking, I'm actually in SoCal right now, so I was thinking, hey, maybe we could do it in person one of these days. Are you still in SoCal right now?
Yeah, I'm in LA right now.
Okay, cool. Sounds good. Lots to talk about. We got this big FSD update. I think it's 10.12.1. And I wanted to go through that with you, kind of line by line, just to gain some more insights on that. But first off, top of the news, or, on top of lots of people's minds, is the Tesla share price. So we've seen, from all-time highs down almost 50% just in the past several weeks. Like, I'm curious, what's going on in your mind? Are you just kind of chill, or do you have
So it
any
looks like a
emotions or thoughts?
great buying opportunity to me. I'm watching the macro to see. I feel like most of what's going on doesn't actually have anything to do with Tesla. And, the macro environment's going to clean itself up at some point. And when it decides to turn around, the next couple of years for Tesla are just going to be incredible. In terms of, people who are following the company or who are looking at what's going on inside. We know, we've been watching them execute. If you're really paying attention, you can tell that they've been executing. But, analysts, people who are external, the show me the money types, right? They want to see it show up in the numbers. And there's nothing quite as compelling as a giant balance sheet and huge revenue and very big earnings numbers every quarter, right? And so we're just moving into that era of Tesla's development where the earnings are going to start being just shockingly huge. And so this transition from, okay, it's not going to go bankrupt to, to, oh my God, it's really going to make a lot of money it's an inflection in attitudes that people are going to have. And it's not going to happen in one day.
Yeah.
I'm sort of expecting the next 24 months, but this is totally overshadowed by, what's going on in China, what's going on in Ukraine, the macro, how much of inflation is structural and how much of it is just supply shock. And all those things have to get sorted out because, they're not just hurting Tesla right now. The NASDAQ, the whole market is behaving poorly. And I kind of feel like I keep thinking, man, the world, and like even Elon with all of his shenanigans lately, was sort of, it's like, it's almost like the events are conspiring to create the buying opportunity of the century, right? But like, there's just all of this stuff that doesn't matter at all to Tesla. That really doesn't. Normally the macro is something to worry about, right? And if it weren't for the fact that they're executing super well, they've got this huge backlog of execution that they've already done, which is going to start paying off soon. And, if they didn't have a demand pipeline that was just absurdly deep, like, it is very difficult to imagine like the macro getting to the point where, it starts cutting into Tesla's ability to sell cars in the short run, certainly to sell cars at a profit, right? Because right now the prices have really been raised to a spectacular level. And yet the cars, the backlog is ridiculous. So, a reasonable concern is, well, maybe the ASPs have to come down. But I don't think a reasonable concern is they won't be able to sell all the cars they can make, right? I think that's off the table.
Yeah, one I think, I would say legitimate, but actually possible, scenario on the negative side is if ASPs come down, because let's say there's a recession happens that's worse than expected, that hits kind of the whole economy and demand as well. So if ASPs have to come down, and say margins come down, then analysts and investors start to project kind of a declining margin, saying, oh my gosh, this is the worst thing, and they project it further. And so you see kind of multiples and kind of the price that investors are willing to give come down as well. So, hopefully it doesn't come down to a recession that severe, but we'll see.
Yeah, sentiment is the toughest thing the toughest thing to understand and to predict. It's the toughest thing to model, right? You can try, but psychology is a weird thing, and all strange events come out of left field. The thing about sentiment is it reverts to the mean by norm, right? By pretty much by definition, it will revert. So you could say, well, maybe the macro will continue to be bad, or maybe the optics of some trivial thing will continue to not perform well for the next 24 months, that's certainly possible, right?
Yeah.
So if you were making a really big, margin bet or something like that, or if you were going to like get into short options and that kind of stuff, there's a risk, The market can stay pessimistic for absurdly long periods of time, especially, I mean, this isn't true of Tesla, but like coming out of the 2000 market crash, the market was absurdly pessimistic about really good businesses for a really long time because a lot of people had been badly burned, in the fall, and it was just like, I'm never going back there again, right? So, and I was invested in some of those, so I got to sit there for months and years and look at just the Wall Street again and again and again, not get it. So that's a real risk. It does happen, and I'm definitely not going to rule it out in my own decisions. But still, the overwhelming preponderance of events are greatly in favor of this. Tesla doing great. And I mean, the business is going to do great kind of regardless. The question is just whether, Wall Street and, investors recognize that in the, 2-3 year term. I think, in 5 years, if you've got Tesla bought and you've got taxis out there and, if they really execute on the things that they are shooting for, then it's kind of absurd to think that at some point, Wall Street doesn't get it,
Yeah.
And money's green, right? Like when they start doing share back, eventually they run out of stuff they can put money into.
Yeah.
Right. There's the dialogue about the potential for a buyback, which, I sort of can understand people's thinking, well, they've got so much cash. Are they really going to need it? Maybe they could put a prop underneath the stock price. But like, I've got this thing, I heard you mention this too, that, they could just decide to own the taxi fleet, right? I mean, that's super capital intensive if they decide to do it. I mean, it's crazily capital intensive if they decide to like build a taxi fleet and own it. But if you believe in the business prospects of that business, it's a great investment, right? It's a really great investment. Yeah. And it's one way to make sure the taxis actually get out there, right? Because if kind of like if you have a supplier who doesn't really believe in your business as much as you do, it can be hard to get them to make the investments to help your business see its potential. And if there's a financial support, if they have to finance those cars or they're going to sell them to somebody else who's going to field them, there could be a limit to which that partner is willing to go out on a limb to believe in the taxi business model. And if Tesla believes in them more, then having a fortress, balance sheet is a way to just like make the bet yourself and not have to rely on somebody else to do it.
Yeah, definitely. So I wanted to ask your opinion on Tesla AI Day. So was it a bit of a surprise that Elon announced this for this summer? It's kind of out of the blue. He hadn't even hinted about it until just an announcement. And so what were your thoughts kind of on, why Elon has announced this?
My first thought, it was kind of, I guess the recruiting didn't go that well on the first one, right? Because I'm kind of surprised that they're doing it again. I mean, they didn't do a autonomy day soon after the first one, and nobody's expecting them to do another battery day really soon. I mean, maybe they will. That would be great. But, they got to air what they wanted to on those events. And I kind of felt like it was over, and I was sort of expecting that with AI Day too. But unlike the others, Elon did come out in front and say, this is a recruiting event. We want, we want to, get the best and get on the radar of the best and brightest. And that, I mean, we've talked before about how competitive it is attracting talent in this space right now, especially, Tesla's tendency to only want the cream of the crop, right? They're much less interested in the B and C players just to fill out the ranks than they are people who can really move the dial on what they want to do. So, and academics, which is where a lot of this stuff comes from. I mean, it's easy. You can make money anywhere, and you can make money in a cushy job, a job where you don't have to work very hard. And Tesla, in certain respects, they don't publish a lot of papers. They're not like OpenAI, showing all these amazing models, or DeepMind, with their Go playing, thing that really attracts a lot of attention. So I can believe that the lack of these super visible accomplishments might mean that they're not as visible to the people that they want to recruit. I want to be excited about it, and I'm excited to see it, and I definitely want to learn more about what's going on. But when they said they were doing AI Day, it didn't immediately make me really happy, right? Because I wanted to get the people that they, there's another way to look at this too. I mean, if they don't have enough people, you could see that as either, well, they had this minimum number of people and they're not getting it. So that's one way. And that's sort of the glasses half empty kind of view. But there's this glasses half full view too, where you could say, well, after AI Day, they got way more ambitious and things are going really well. And they really want way more people than they thought they did before. In other words, not so much that they're unable to satisfy their demands, but their demand is growing much faster. Their demand for this kind of talent is growing much faster than they thought it would. And in that sense, I'm super bullish on it because, obviously, I think these technologies are a cornerstone of productivity growth in the future and making people's lives better. And to the extent that aggressive companies want to get in and make really big investments and move really fast, I'm a huge fan of that.
Mm-hmm. Yeah. I'm thinking, what do you think would be the highlight of AI Day? Is it, obviously, the context is recruiting, but is it just to give an update on, FSD, training, dojo? Is there any kind of focus you think AI Day will have this year?
Well, if you think that, let's see, if the goal is to attract talent, then I would guess that they're going to try hard to highlight to that audience the opportunity that coming to Tesla is going to present them, right? And things that people will get excited about are the ability to work on really interesting projects, like cutting edge stuff, the ability to make a difference. That's a place where Tesla already does pretty well. Another thing that's really interesting is companies that have really great toys, right? Because so much of what goes on, just for example, a lot of the really interesting stuff happens at scale. So having a lot of resources in your data center or really fast computers or unusual resources, that will definitely be, attractive to the kinds of people you probably want to attract. Not like people who aren't just going for the paycheck, but people who are going because they really into the work. They really want to see the field move forward and they really want to try to make a contribution. So in a lot of ways, that was kind of how AI Day was bent the first time, right? They didn't try hard to talk to the public. They were talking to a particular audience. And I would sort of expect more of the same and maybe them to go even further, depending on whether the reason they're having another one is because the previous one wasn't successful, or whether they're having another one because they want even more people because they're going to grow that business even faster now.
Yeah, I would lean on the second, just because I think Elon getting more involved, kind of with FSD and Optimus, him pushing the programs, he's basically putting this as top priority, for Tesla, their AI ambitions. And so it would make sense to him, to have it more frequent than not. Just to update people to get the best of the best. I don't know. That's my kind of default interpretation.
I shouldn't say I'm not. I don't want to say I'm pessimistic about this. Yeah. I was kind of caught off guard because I wasn't expecting it to go again. And I thought the presentation was pretty impressive. But a thing you could do is demo Optimus, right? If they really show progress on robotics that is surprising to people out, because FSD is not. Self-driving cars are not. It's not, in a weird way, it's not really a great benchmark because it's a really hard problem, and most of the progress happens, as FSD beta users, it happens incrementally. So you can have what, from the experience of driving the car, is a relatively minor advancement where an expert would look at it and say, that's amazing. We've been working on that for so long. We've never been able to do that before. It could be a small thing, but a critical thing. Yeah. And people who aren't already in that field, they're not going to get it. right? But robotics is much more of a high profile thing, especially humanoid robotics, right? I mean, everybody watches the videos. Most people who are kind of interested in that field have a pretty good sense of like what the state of the art and capability is. And so if Tesla trots out an Optimus that can juggle, I mean, there's all kinds of very things that are really difficult for robots to do right now, that showing progress on that would be a very, a simple kind of highlight that we could really do. And there are a lot of other things that you can do too at the algorithmic end, stuff that's harder to explain.
Yeah.
So they could have any of those.
Yeah, I was thinking like with FSD, people are always going to compare it to human driver. So anything less than a human driver, that level of safety, it's a disappointment, right? And so basically almost anything you demo, it's like, it's a tough call. But with robots, it's almost like anything you demo is like, whoa, that's kind of cool. You got a low bar of expectations with robots.
There was a time, I have talked about this before, but when I went to the DARPA Urban Challenge back when it was to me, it was kind of the dawn of the self-driving car thing. Because up until that point, it was just like only weirdos were interested in it because it seemed infinitely far away, right? And there was like this moment when all of a sudden, wow, this stuff really works. That where it crossed that line between people weren't impressed that it could do anything at all. They were starting to think, how long until it can do everything? When I learned Japanese, I remember measuring my progress. In the beginning, you measure your progress in terms of how many words you know. And then, but once you get pretty good, you're always measuring your progress in terms of how many words you don't know, right? I mean, that's almost the whole experience. So it goes from look how great I'm doing to, oh my God, I'm still terrible, right? Because you're measuring it from the other end. And cars have been in that measuring it from the other end zone. Like, what can't it do? And that's all we talk about.
Yeah. Do you think so Elon did say that they're going to show a sneak peek or sneak preview with Optimus. So what do you expect? I mean, a few questions here. Do you expect the form factor to be what they showed last year with AI Day, and also at the Gigafactory opening, they had a model there. Do you expect that form factor to stay the same? And the second is, do you expect Tesla to show at least some basic functions of walking, maybe picking up some boxes, moving them, like some basic stuff like that?
That would be pretty impressive if they did it. I mean, doing it in this highly scripted way, the way we see the Boston Dynamics robots. I mean, that's it's impressive in a certain sense that a machine can do that at all, but it's unimpressive in that those things are unbelievably scripted in order to get that behavior. It's not, it's not off script or ad lib or whatnot. So doing something complicated off script would be, impressive. Like if you had a robot come out and fold a T-shirt and put it in a suitcase and zip the suitcase, like, the robotics world would fall over sideways, right? Like that's how hard that is. The lay audience would look at it and say, I don't see what the big deal is, right? But there are things that are super simple for humans that we want robots to be able to do that they haven't been able to do for a really long. Just even locomotion. Like there are aspects of locomotion that are tough. Like building a humanoid robot, you just put it in any environment that a human being could normally walk in. Walk through a river, walk through snow, walk on a sandy beach, walk up a gravelly hillside, walk upstairs, avoid obstacles where there's a lot of rocks. I mean, to build a system that can just do all of those, a humanoid, like a bipedal balancing robot that walked through this stuff, like that's an unsolved problem. And and it's not a slightly unsolved problem. It's like over the horizon unsolved from the perspective of people who work in robotics today. So like demoing that would be, shocking to people in the space. And it would, it would suggest that Tesla's serious and competent and well-resourced and so forth.
I feel like with robotics, Tesla could give like much more frequent updates, even like every 6 months or 3 to 6 months, and they would to show progress. I don't know if I doubt they'll do it, but it seemed like at AI Day they showed kind of their ambitions, but they didn't show like a robotic demonstration, of where their robotic capabilities are. So fast forward a year later, I think it's a great time for them to actually say, hey, we have a robotics team. This is what we're working on. This is how much we've we've come, and this is what we're focused on going forward for the next year or so. That could actually, I mean, maybe it's a robotics recruiting event, a decent chunk of it too, you know? I mean, what are your thoughts?
That would make sense. Yeah. I mean, it's definitely the case that on AI Day that the self-driving car technology was the star of the show. And you can imagine that from a recruiting event standpoint, like the people you would be drawing would be the people who feel like they have something to offer there, the people who are interested in that problem, the people who've worked in that space, right? And if Elon has said a couple of times recently, like, Optimus is a big deal. We're going to really resource that. And it's probably the most important project we're working on this year. So maybe they didn't get the robotics people that they wanted to last time. And if that's the case, then it'll be all about Optimus.
Interesting. All right, so I want to dive into the latest FSD update. So it's 10.12.1. We've got like 18 line items for their log. And I figure the best way is just to go one by one and see if, I could learn a bit more about what Tesla is doing. And as a byproduct, I think others will also be able to learn about this. So the first update was this upgraded decision-making framework for unprotected left turns with better modeling of objects' response to ego's actions by adding more features that shape the go and no-go decision. This increases robustness to noisy measurements while being more sticky to decisions within a safety margin. The framework also leverages median safe regions when necessary to maneuver across large turns and accelerating harder through maneuvers when required to safely exit the intersection. So is this all about left turns, basically how it's deciding this part?
Yeah.
Okay, so what are...
Yeah, I mean, left turns are hard. Left, you have this window you got to move in. Frequently, you've got limited visibility. A lot of times, it's a high risk turning in front of fast moving oncoming traffic. Plus, there are a lot of things that you have to keep track of at the same time. If you're left turning in an intersection, you're not only responsible for the people coming, but maybe people doing right turns. And a lot of times you're the low man on the totem, even though you might have the right of way, right? You have to watch for pedestrians and people turning right and all this other stuff. So it's a complicated and a high risk maneuver. It exists in huge variety in the real world, right? I mean, left turns, there's so many different kinds of intersections. So it's a tough problem. And all of these capabilities, whether it's a left turn, right turn, going straight, parking, whatever, you always want to start with the simplest, most general algorithm, get it out there, see how it works. And then you discover the places it doesn't work. And then you add complexity to deal with the places that it fails. Because you don't want to start with something complicated. For one thing, you don't want to solve problems that you don't actually have. And for another, complexity adds its own problems. So you start simple and you work your way up. So more than once, we've seen them talk about unprotected left turns. And in this case, they're adding, like my read of this is they're adding features that they didn't have before to deal with particular corner cases where they're seeing problems in the real world. So the last one I think is kind of interesting, where they talk about using a median safe area, right? Mm-hmm. So this is, there are lots of roads where, you're turning left onto a road and the right and the left are well separated in space. And there's a place in the middle of the intersection where you can stop. And that way you only have to, you can do the oncoming traffic from the left first and then from the right on the second one and complete your turn to break it into stages. But that's a pretty complicated maneuver. And I haven't seen it do that. And I always think of Chuck Cook has what I call the UPL from hell. He's got this unprotected left, which is tough. It's a really tough one. Visibility is tough, and he tests it a lot. We've got to, there's all of this data that you can see on his YouTube channel of him trying this over and over on these different things, and it has this tiny little median space in the middle. Where, Chuck, who knows that turn well, he stops there when he makes his left turn. If the traffic is busy, he'll jet across the first part, wait. And it's because it's just a tiny little thing. It's barely big enough to hold the car. I wouldn't do that if it was me. If the car could do that, I would be super impressed because that's tough. It's hard to judge the velocities of vehicles at these weird angles. And there's trees and occlusions and there's a lot of stuff you have to know that you have to predict well that situation, and you're not going to do the maneuver unless you're really confident of what you're seeing, because it's dangerous, right? The car's got to have super high confidence to do that. So if the car's willing to do that maneuver, you know that they're doing really well on the confidence of their perception. So like, I thought that is a really standout aspect of this particular thing. But the rest of it, basically saying that when you interact with traffic, there's predicting what the traffic will do, but there's also predicting, like, what will the traffic do if I do this thing, right? That is, if I turn left in front of this guy, what will he do? Will he speed up, slow down? Is there enough space, right? Will he change lanes in the middle? Now, for oncoming cars, that might not be as big a deal, but for pedestrian or other road users, like anybody else who could block your path or who just happens to be sharing the road with you and that you have to take into consideration, like predicting how they respond to what you do it's kind of a next level challenge. There's assuming they're going to keep doing what they're doing. And then there's like, if I do something, what will they do? And taking that into account. So, and they're basically saying that they're adding model elements to do this, to try to predict how the behavior of the other people that you're going to interact with might change what they're doing in response to what you do. Because if you, on a left-hand turn, because you have a window of time that you need to complete it frequently because you've got high-speed oncoming traffic, you can't afford to be very wrong about things that might prevent you from completing your maneuver in a timely manner, right? And so those predictions are important.
Yeah, I mean, it's interesting. Just this first, update or explanation. I mean, adding kind of the predicted response of other objects to your actions, but also using the median kind of safety area. Like, this seems like pretty advanced maneuvers or advanced features in this overall stack of driving. It's not like a basic keeping between lanes or making right turns. Like,
no, it's they're starting to get into the weed, which, there's things that are great about that. Like, it's great. A lot of the features you're looking at on these things they've moved beyond being worried about safety, and they're starting to worry about comfort and smoothness and like not disturbing other traffic flow. Like, it's clear that, in the hierarchy of things you want to accomplish, like, safety is on top. And you mostly don't spend a lot of time addressing the things lower down the list until you're really confident you're doing a good job on safety. So the more we see them doing features down the list, the happier I am to feel like, they feel like they're getting the safety down, right? Because, that's the single most important thing. And there's definitely aspects of this that are like that. I mean, they don't have to do a great job with UPLs right now for as long as you got a driver in the car, because you've got a driver backup. They can afford to take chances, but they also don't have to be super smooth, right? They've got so if they're already devoting significant resources to trying to make the driver more comfortable about the maneuvers that the vehicle is taking, like, that's a good sign. It's like they got the basics down. Now, there's another aspect of this, which you can say, well, is a little bit pessimistic, and that is, it would be great if you could come up with a simple general algorithm that just worked great on left-hand turns, right? And there are a lot of things that's true of. Like, there are a lot of things in the road system where you come up with a general way that you're going to go at the problem, and it just works okay, and you can stop worrying about it. And this, the fact that they're adding another layer to anticipate what other road users are going to do in response to what you do, that suggests that, this maneuver is turning out to be pretty complicated, and they're going to add more bells and whistles to it until they get it right. That introducing complexity can make a system brittle, and it's more opportunities for bugs and that kind of stuff. So it kind of cuts both ways. It's great to see that they're getting into the detail. It's unfortunate that they have to. Right?
Makes sense. Number 2 on this 10.12.1 update says improved creeping for visibility using more accurate lane geometry and higher resolution occlusion detection. All right. So, what does that mean here?
So creeping. So there are lots of situations where you come to the intersection, you stop at the first place that you would like to stop, and you can't see what's in the intersection well enough to be able to safely move. So you move forward some past the original stop line to get better visibility. And it's a surprise. This is a thing that is harder than it seems, in the sense that, I promise we won't spend as much time on all the following points, but there are a couple of interesting ones right here at the beginning. it's it. So if you're thinking about moving forward, there's this cost benefit, trade-off that you do. The farther forward you move, the more at risk you are of either disrupting traffic or having something like that go on. And the reward is being able to see enough better that your confidence of being able to do the maneuver safely goes up. And making that prediction is pretty tough, because when you think about it, like, if the reason you're creeping is because there's some trees between you and being able to see down the road, you have to be able to because sometimes creeping forward actually makes it harder to see. Like, everybody's had that experience where you come to an intersection and there's a car parked at the curb on the corner, and you can see behind the car the oncoming traffic. But if you move forward, as soon as you move forward, you won't be able to see it anymore. So, like, creeping isn't always a win. Sometimes creeping is a loss. And to predict whether you're going to gain more than you lose, you have to have a pretty good understanding of, like, what it is you want to know, what you have to do to get that additional information. Like, if the thing you're worried about is oncoming traffic, you want to be able to see farther down the road. Well, you got to know what shape is the road, where's the traffic coming from, where are the spaces I can see through, and do they get better if I move forward or not, and how far forward might I have to do. So, So there's more to it than it's in the simple case where you're just moving forward and getting a better view. Of course, it works great, but there are all of these cases that aren't the simple case. And I think that's what this is targeted at. The situation where you've got a tree near the car, you've got a pole near the car, you have another car near your car, and you need to sort of, like, how far forward can I move reasonably and get what I need to know in order to do the maneuver I want to do.
Got it. So, I mean, basically, like, let's say there's a tree where if you move completely forward, then it's going to block too much of a view. So maybe if you move a little bit forward, like halfway, you'll get the best view. But so now this update moves in that direction, basically to know how to creep the best way.
Yeah. There's another dimension to the trade-off, which is you can always just wait, right? Like, if you don't have great visibility or you don't have a lot of confidence, it's often the case that you can wait for a better opportunity, or instead of turning left, you can turn right. You can do a different maneuver. And so part of the trade-off is, you don't want to wait forever. How long are you willing to wait? What can you do to potentially reduce the wait? And in what situations is it better to wait, right? Like, there's that trade-off to figure out.
Makes sense. Number 3, reduced instances of attempting uncomfortable turns through better integration with object feature predictions during lane selection.
Right. So this is another, they're trying to make the turns smoother, and they're doing it by adding additional features that allow them to make better predictions about what will happen when they do their turn.
Is this all turns, left, right, just changing lanes, or?
Yeah, they don't call out the left on this. Okay. So it's, object feature predictions and during lane selection. So you're going to turn right or you're going to turn left, and there's a pedestrian in the intersection, or there's another car that's coming through an intersection. And maybe the right thing to do is to turn to the nearest lane or the second lane. Maybe you have that option. And there are certainly lots of situations where you have that option. So it kind of looks like this is either for predicting the lane choices that other vehicles will make, or for being able to predict what the consequences of different lane selections for the ego vehicle are.
Okay, got it. Number 4, upgraded planner to rely less on lanes to enable maneuvering smoothly out of restricted space. Yeah,
so they changed the planner. They're going to keep changing the planner. The planner is something people complain about a lot. The planner is the bit that basically it takes what you know about the situation and turns it into, like, what should I do to get where I want to go or to achieve my immediate objective. Once upon a time we had the tyranny of lanes, where lanes totally, what it thought were the lanes totally dominated with the options that it had to do. And when you get to FSD, of course, you have to free yourself from the tyranny of lanes. Sometimes you have to change lanes or straddle the lane or cross into oncoming traffic. And deciding, but you don't just do that, right? You move into this kind of hybrid area where or to some extent you consider all the available space and you use the lanes as a guideline. And how strong a guideline are they? How much do you allow them to constrain what you're going to do? So in this case, they're moving gradually farther away from the tyranny of lanes, and they're giving the system they're putting together a planner that has more opportunity to do more with the free space that it has, instead of being stuck with sort of simple rules about what you can do in a lane.
Got it. When it says maneuvering smoothly out of restricted space, is this basically space that the car shouldn't be in?
Maybe, yeah. So maybe you're moving along and you have construction in front of you, and that's restricted space, and you can't move into it, right? So maybe you ended up in the restricted space inadvertently, and need to get out of it. Restricted space could also be just space that's occupied by other things, right? Like there's a vehicle, an obstacle in the way. That's probably not what they mean in this case, because they probably would have called it out. But restricted space is someplace where you're not supposed to do something, obviously, and that has been a constraint apparently in their planner before.
Yeah. Number 5, increased safety of turns with crossing traffic by improving the architecture of the lane's neural network, which greatly boosted recall and geometric accuracy of crossing lanes.
So it sounds like this is an extension of something that they introduced. This is the headline feature in 10.11 was they added a neural network to do lane prediction, especially for crossing lanes. So they're making changes to that, it looks like.
And so when you're talking about crossing lanes, is it just making like a changing lanes, or is it like turning, like going across a street and, crossing like lanes on a street perpendicular?
Crossing lanes are lanes for crossing traffic.
Okay.
So that could be a lane that could be a road that comes in and intersects and tees with the road that you're at. So that's one way to interpret it. Another one is you're at an intersection and there are multiple lanes that are crossing. You have multiple crossing lanes. And so, in intersections, usually there aren't explicit lane markings. So the system has to see 2 lanes on the left and see 2 lanes on the right and know that these 2 match up with those 2, and cars in that lane over there are going to end up in this lane over here to predict paths and that kind of stuff. And that assignment can be tricky in intersections because frequently all you've got is the curbs and some faded markings, right? And as a human, you go into that and you infer the implied paths for all the different ways you can go. And that helps you predict what other people are going to do. And those predictions help you figure out when it's safe to go and when it's not safe to go. So when they moved to doing a neural network for this, I was really pleased because this is the kind of perverse problem that seems really simple. But when you start writing the code, you discover it's just intractably difficult. And it's a natural for having a neural network do it. And when they were first talking about it, I was like, you're not already using a neural network for that? Like it seemed so hard to write the rules to do it. And I was expecting it to get a lot better. And it did get a lot better. Like the vehicle's ability to handle intersections, especially complicated intersections, is just next level after they rolled that feature in. And they're not done with it. Like they're continuing to make improvements. I mean, they cite recall, greatly boosted recall and geometric accuracy of crossing lanes. So basically how accurately the system is predicting what a human would say the lanes are has improved significantly with these changes that they made. So I think what we'll see is better, smoother turns and transitions of not obviously simple intersections, not your weird angles or where the lanes don't match on either side, or where you have a T and it's occluded or something like that.
Got it. And it kind of perhaps leads into the next one, number 6, improved the recall and geometric accuracy of all lane predictions by adding 180,000 video clips to the training set. I mean, it seems like this is one of the things, like improving, lanes, by adding a bunch of video clips is one of the things that it seems like comes up a few times in this update. So is it as simple as just like 180,000 various clips of different lanes and stuff that they added into, their training data, or like?
Well, we've talked in the past about how they gather clips, right? They push a criteria for something that they're looking for. So they might, just talking about, to give some examples of how you might do it on the lane things, right? Is they might, have a trigger that tell the car, if the driver overrides you with a lane change in an intersection, say, and it's this kind of intersection, record the data, send it to us. So they can look for situations where drivers are intervening more than the baseline, highlight those as places where the system is weak right now, do a little bit of analysis to categorize them, build a trigger, send it out, capture the triggers on these problematic situations, and turn those into data that you feed into the system.
Got it.
Right.
And,
so that
you label the data.
Yeah.
Right?
The autolabeler does it. So when it says clip, this means autolabeler at this point, right? We know they're using the autolabeler. They explicitly call out the autolabeler. But one of the things I wanted to highlight on this is they added 180,000 video clips. So, a clip, it's 288 frames per second, 8 cameras at 36 frames a second, right? So these are high def, 1280 by 960 frames. So, sizable. So we've heard different estimates of how long the clips are, up to 60 seconds or whatnot. But if they're 30-second clips, that's 1.5 billion images. So to incrementally adjust this one feature, this is just one of many, many features. They added a training set that's probably bigger than every single labeled vision training set that has ever been compiled, like maybe 100 times bigger. Like 1 million images is considered a really big labeled training set, a huge labeled training set. And they're just doing an incremental adjustment to a feature, and they're adding up 1.5 billion images to it. It's just the scale. It's nuts what they're doing.
It makes a difference also if these are 180,000 like generic, just like, lane clippings that you can get anywhere, anytime that, versus what you're saying is they could be, and they likely could be triggered type of difficult edge case lane situations. If that's the case, that these are actually kind of the difficult.
And these are additional ones, right? These are ones that they added in order to get this level of improvement. When you first start training the system, you just go out and you collect your clips at random, your data, because any data is useful data at that point. But you pretty quickly get into diminishing returns, where just adding any old data doesn't make your system better nearly as fast as if you look for places where you're failing and you get data there. And that's the whole point of the whole trigger system that they have, because it's so much more productive to gather data where the system is weak and make it better there than to just gather more data and throw it in. So,
all right. Because when you think about it, how difficult is it to replicate, these 180,000 extra video clips? If they are edge cases triggered by users, and this is extremely hard, I think, to replicate for other, people.
Yeah. How many cars do you have to do that, right?
Yeah.
180,000 clips. And this is just the interesting stuff, right? So it's a tiny fraction of the driving that people do most of the time. Yeah. When they add a new feature, almost any kind of data is useful. But, this is a refinement of an existing feature. So presumably, I don't know how many clips they already had in there. I'm just like the idea that they added 180,000 clips to the training set is just like, it's just like
yeah, definitely.
A scale matters. There are supervised there's labeled data and there's unlabeled data. And a lot of models today are getting the so-called self-supervised models. They don't need labeled data. You can just, you still want to curate the data because you want a nice statistical distribution of different phenomena that you want your model to be able to deal with. But labeling data is really expensive. And so as a consequence, training with labeled data where some human has looked at it and said that this is the answer the neural network needs to produce, that's labeled data. And it's pretty labor intensive to produce that stuff. Even with automated tools and stuff, it can be really intensive to do that. And as a consequence, you just don't see massive data sets that are labeled. And this is, the autolabeler is a pretty brilliant, idea that you take a clip and you have correlated inputs from these different cameras across time and across space, and you have a big computer sit on top of this clip and figure out what the 3D geometry of the scene is, backwards and forwards. Then you label everything inside the scene. You can push those labels back so that every single frame that went into it gets a label for every single object that's in that frame that you might be interested in. And you get a 3D model out of it, not just a static 3D model. You get a dynamic moving 3D model where the pedestrians are all moving, the motorcycles are all moving, and your car is moving. So the trees and everything are moving past you. Like that is an incredible set of labels for training a network. And labeled data is much more effective than unlabeled data is. So it's difficult to overstate the power of having access to this kind of data for building a system.
Yeah, definitely. Number 7, reduce traffic control related false slowdowns through better integration with lane structure and improved behavior with respect to yellow lights. Yeah,
so that's pretty self-explanatory, right? They're getting better at understanding how the traffic will flow through an intersection with complicated lane structure so that they are better about timing yellow lights.
Okay, got it. Number 8, improve the geometric accuracy of road edge and line predictions by adding a mixing coupling layer with the generalized static obstacle network.
Yeah, so they kind of have generally 2 different kinds of outputs that they generate for the 3D environment. And one of them is a dynamic map that has cars and people and stuff that moves around. And then there's the static one, which is like barriers in the roadside and trees and that kind of stuff that doesn't move around. And you've seen, I don't know if you've, Tristan Rice Fry he shared some videos of the static, which is just basically an occupancy map of the environment. So I have this static neural network that puts out that thing, and they have been using it for making certain driving decisions. So here they're not just taking that and making decisions based on it, but they're taking an intermediate product of producing that static map, and they're blending that data in the neural network. That's what the crossing mixing layer is. It's like it's a layer where these 2 parts of the neural network can exchange information because each of them knows something that's useful to the other side. One of them is the 3D object map, and the other one is this. It's a road edge. What do they call it?
And line prediction.
Yeah. So you can imagine that knowing where there's a barrier or a curb is something that's useful for predicting where a lane is. And likewise, knowing where the lane is useful for understanding how to interpret what you're seeing in the static object map. So previously these weren't linked, and now they are, so they know about each other. So an example where this might come into play, something that I encounter really commonly in construction zones in Los Angeles, is you're zipping down the fast lane and you have these temporarily placed K barriers that are kind of nominally aligned with the lane, but every once in a while there's one that's just off. It's just like sticking into your lane, right? The lane, the logical lane you want to follow goes around. You want the system's perception of where the lane is to move away from that K barrier if it's jutting out into the lane, right? But the thing is, the striping on the road and whatnot might not be giving you a good indication of that. And you need the static object map, the map that's telling you there's this static object, which is overlapping with your lane, which you should take into consideration when you think about not where the marked lane is, but the logical lane, the lane that you want the vehicle to follow is.
Got it. Interesting. Okay.
So it'll get better at those kinds of things because they're sharing data between these 2 pieces of the system.
Got it. Number 9, improve geometric accuracy and understanding of visibility by retraining the generalized static obstacle network with improved data from the autolabeler and by adding 30,000 more video clips. So is this just kind of describing the number 8, the last one we talked about?
It might be talking about how, let's see.
Like how they improve
it? Well, they added this note seems to be saying that in addition to this mixing network that they added a lot more data and have been doing more training on that. 30K, a mere 300 million more images added to the system to improve this. Also, an interesting thing about this is they talk about improved data from the auto labeler. So somebody on Twitter pointed this out, and it's a great observation, which is that the auto labeler is a tool that's under development and it gets better. So, you have auto labeler version 1.5 and you have 1.0 and you use 1.0 to build a corpus of data. But then later you make a 1.5 and it gives you better labels for more objects over a wider area. Maybe they're more accurate. So when auto labeler 1.5 shows up, you can you run it over all those clips again, and all the data that you generated from those clips is suddenly better. And there's like this virtuous cycle that the better the labeler gets, the better the cars get, the better that network gets, and then that allows you to narrow down to places that the car isn't doing well because the auto labeler is not labeling it as well as it could. So you get this feedback loop where the better the auto labeler gets, the better the car gets, the better the car gets, the better the auto labeler gets, right?
Interesting, huh? Okay. All right, let's go to number 10. Improved recall of motorcycles, reduced velocity error of close-by pedestrians and bicyclists, and reduced heading error of pedestrians by adding new simulated and auto-labeled data to the training set.
Yeah. So that one's pretty straightforward. They, look at VRUs close to the vehicle, wanting to get better. So they added more data. And here they call out simulated data too. So simulated data in V.11, they talked some about, in the notes for 10.11, they talked about how they were adding simulations for dealing with VRUs that were close to the vehicle, because that's data that's hard to capture. You want to do a really good job with motorcyclists and pedestrians and whatnot, but that's a situation that normally you avoid. The car will avoid it. It'll brake to avoid people. So it's the kind of data that you want to gather in simulation because it's hard to gather safely in the real world. And this I think is an extension of that. They're just continuing to work on that feature.
Got it. Number 11, improved precision of the quote-unquote is parked attribute on vehicles by adding 41,000 clips to the training set. Solved 48% of failure cases captured by our telemetry of 10.11.
Yeah, that's a lot. That's a pretty big improvement in performance. So it'd be interesting to know what their failure rate was before, but they basically cut their
failure rate in terms of recognizing if a car is parked or not.
There's a vehicle at the side of the road. And, sometimes it can be hard when you're approaching and seeing it to know, is that car stopped or is it parked? Like a car can be stopped in a parking lane, or it can be parked, people do stop and where parked is that car's not going to move anytime soon. I need to treat it as an obstacle, and stopped is the right thing to do is wait for it to move. That can be kind of subtle and a super contextual, dependent aspect of a stopped vehicle. And it matters a lot in urban driving, right? Because you frequently encounter cars that are stopped, and how you behave around them. Like, the classic one is a bus. A bus is that bus stopping because it's the end of its route and it's going to be here for 20 minutes? Or is that bus stopping to pick up passengers and I don't want to go around because there's a lot of traffic?
Interesting. Got it. So what do you think these 41,000 clips are? Do you think they're triggered things, or just clips?
There are 41,000 examples of where the car guessed in the past that it was parked or not, and it was wrong.
Oh, interesting. Wow.
Right? So every time it's wrong, you capture that data, goes back into the system, and the system gets better at that situation that it got wrong last time.
Wow. So you're saying that likely, we don't know for sure, but likely you're saying, so the car is guessing, let's say the car in front of them or next to them is parked, but then the car actually moves, so it's not parked. Yeah. And so that's a trigger to send the video clip. And then the team is able to analyze and label.
Especially if it results in an intervention. Like, you're driving down the road, or the AP is driving down the road, and it's going to drive past a car that that it judged was parked, but that car moves in front of you and the driver has to intervene. Okay, so you captured that because you guessed wrong. It led to an intervention, and you add it to your set.
I mean, that's pretty hard data to get if you don't have like the fleet and the hardware and all of that.
All of this data is, I mean, on this scale, right? You know, 1 billion images, you know, 180,000 events that you record. The ones that made it through the filter too, they grab 180,000 events and they come back and like probably almost all of these events have they either run through some algorithm that evaluates them to decide whether they really want to use it, or a human being looks at it to see if it's actually worth using. I mean, the ingestion of the data pipeline is probably much larger than this.
I mean, one thing is it's also impressive is you need the right hardware on the cars to get this data, meaning you need to be running the current neural nets who are predicting is that car parked or not, and then to trigger it, right? Like you can't
They called it out here. They said captured by our telemetry of 10.11, right? So they added telemetry to 10.11 to capture these cases.
Yeah. I mean, you can't just, you know, run a dash cam or something, you know, or stick something. You need, and that's the thing about the hardware with the neural nets, it has to be like efficient. You can't have these, you know, power hungry, you know, huge computers.
And you have to know where you're failing, because part of the thing is, you know, there's so many categories that interventions could go into. Like, what was the cause of this? Like being able to say, this is the next thing we should work on. Let's capture that data. You know, you have the telemetry from the vehicles to tell you where you're not doing well. And then you can decide to assemble, to push out triggers to capture that data, to fix the problem. Right? So you need not just the capability to collect the data once you've got the trigger, but you need the capability, you need to be getting enough data that you understand what the right trigger is.
Got it. Do you think the release of FSD Beta to, is it like almost 100,000, I guess 100,000 users right now, is that amplifying or speeding up the process to collect data just because you have more triggered events, you know, using FSD Beta?
Yeah. I mean, the more beta cars you have, the more beta data you'll be able to take. There are lots of events that an autopilot car is not going to be able to capture for you, because like a lot of, there are triggers that can be captured either way. But there are a lot of triggers that you can only write if the car is actually running FSD Beta. Because as we were talking before, you know, if you're driving down the road and your car has FSD Beta, but you're not driving in FSD Beta, it's still running in the background. So you're driving down the road and it's saying parked, 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 not parked, not parked, 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 parked. So it has an opportunity to see, oh, I was wrong about that when it moved after I decided that it was parked, and it can do a capture, right? Okay. Even if the human is driving, but it's got to have the FSD Beta data, the FSD Beta build in it with the recent version that's actually doing that parked, 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 parked. Oh, I got that wrong. You know, it's got to have that code in it.
Got it. All right, number 12, improved detection recall of faraway crossing objects by regenerating the data set with improved versions of the neural networks used in the autolabeler, which increased data quality. Okay.
Yeah. So this more autolabeler virtuous cycle stuff. In this particular case is kind of interesting. You could imagine when they first build the autolabeler, like it's got a set of neural networks in there which do the first pass on the data, including, you know, all the correlation they do between the cameras and stuff like that. And so maybe in the beginning, they're not good at spotting like a pedestrian crossing the street 2 blocks ahead of you. You know, it's not very many pixels and the scene's not very good. But as the you know, the car gets better, they get more data, they train a bit more of that. Now they can put those, you know, better neural networks into the autolabeler. And now the autolabeler can reliably label that pedestrian who's 2 blocks away. So previously, the data that you were training the car on, it didn't have a label for that pedestrian because the autolabeler wasn't doing a good job of spotting because they were too far away. So in this particular case, they've identified, you know, distant crossing objects. So, you know, something that's far enough away that it's small, and crossing the path that, you know, that your vehicle is going on, which could be a car. You know, I mean, crossing objects at distance, especially in urban settings, are sometimes it's a pretty tricky thing to do, because if the only clear space is the intersection, you only get to see the vehicle or the pedestrian for an instant. So having a label for like a motorcyclist who jets across an intersection 2 blocks ahead of you is hard, right? You don't get very many frames. He's moving pretty fast. There might be motion blur. There's, lots of things that could contribute to it. So having the system get better at that, because the auto labeler got better is a useful thing. Interesting.
It seems overall the capabilities of the neural nets of the whole system identifying objects, further away is just improving. It's gist of it, right?
Yeah, one of the things I thought was interesting about this is that they're stretching for, one of the things we haven't had, we don't have one set to rule them all yet. We don't have the single stack, one stack to rule them all. And we have been, the FSD code has not been up to driving very fast on the highway. And in fact, we're still in the thing where if you don't have radar, you're still stuck at 80 miles an hour. And, when I see, improving detection of distant crossing objects, I imagine, this is an attempt to improve the safety of, knowledge, improve the vehicle's knowledge of important stuff, that's well down the road, so that we can go faster safely.
Mm-hmm. Makes sense. All right. Yeah. So far, we still have five or six more items, but it seems like this update is decently significant. I wouldn't be surprised if, they would have called it version 11 or something. It's got some decently, good improvements in the overall, system, but, yeah. Anyways, moving on to 13. 13 says improved offsetting behavior when maneuvering around cars with open doors.
Yeah. So the open doors, I'm kind of surprised. Until I never noticed how common open doors are as something that you have to deal with until I was sitting there in my car with it driving down the road and I saw a truck door open, and they were like, oh, because, sometimes people open the door a little and they wait for you to go by. Sometimes they flip it all the way open. They don't see you. Sometimes they get out right away. Sometimes kids get out right away. It's a complicated thing to do. And, the way to deal with open doors frequently is move into oncoming traffic. If you're in residential areas where open doors are, a pretty common thing, or have to change lanes, so the offsetting behavior of how far, given how fast I am and that particular configuration of door and human and whatnot, how far do I have to move to be safe, considering the potential for oncoming traffic and stuff like that?
That makes sense. It seems like open doors eventually could be one of those scenarios of superhuman capability by the neural nets, because eventually these neural nets will be able to scan all of the cars, that are parked, and then see which of the cars have human beings and see the types of motions they're making, and kind of have a probability of whether this door would open or not. And so maybe even being able to predict, when the doors or how the doors will open, which cars are more likely to have their doors open and to be safer around those cars. It just seems that has potential over time to be one of these superhuman, capabilities.
Well, so, one of the things that at least last time I checked it didn't do it. You have the label for the parked cars. Adding a label for there's someone in the driver's seat, or there's someone in a road adjacent seat, to focus more attention on that vehicle, to anticipate the possibility the door might be open. That's something I do is I think I do it. When I'm driving down a narrow road and there are car doors that could open in front of me, I'm frequently looking at the vehicles to try to understand if there's somebody inside them. You could see it doing that and maybe doing it pretty well. I think that the machine's main advantage is being able to look in all directions and having faster reflexes and not getting distracted. Mm-hmm. Right. A really attentive human can do a pretty good job in most of these situations.
Mm-hmm. Yeah. All right. So number 14, improved angular velocity and lane-centric velocity for non-VRU, so vulnerable road user objects, by upgrading it into network predicted tasks.
Yeah, so this is great. So they're now estimating the instantaneous dynamics of other vehicles around you, like, exactly how is it moving at this moment in time with a neural network. This is, it, it,
So what were they doing before then?
they were apparently using a heuristic, right?
Huh,
Not a neural
okay.
network. That's what I take from this.
Interesting.
Or it's possible that they were, they probably weren't using a neural network for the primary determination of those numbers, and they've moved it to a neural network. And this is one more step in these, having software 2.0 eat up the whole task.
So when it talks about angular velocity and lane-centric velocity, like what are they talking about there?
So lane-centric velocity is how fast you're moving relative to the lane. Angular velocity is how fast the car's rotating. Like if you're in a turn, how tight is it turning, right?
Got
like
it.
how quickly is it rotating about its axis?
Got it. Okay. So they're moving this stuff into neural nets, which should be, they're doing it because it's obviously they're finding it to be more accurate. Their neural nets are developed enough and they have enough capacity or enough focus and ability to improve this. So it should improve the overall system if you are able to predict and analyze each of the objects, how fast they're moving and what direction, etc. Right?
All of these things are the system getting better bit by bit at looking at all of these different at understanding its environment. And it's going to allow it to make better decisions. We'll just see it get smoother. It'll make fewer mistakes. There'll be fewer interventions. There'll be fewer times when you're uncomfortable.
Got it. 15. Improve comfort when lane changing behind vehicles with harsh deceleration by tighter integration between lead vehicles, future motion estimate, and planned lane change profile.
Yeah. So AP, I guess these are FSD nodes. I see this on AP quite a bit, where you make a lane change and, in traffic, you have lanes that go faster, slower, faster, slower. A car wants to make a lane change. So you wait for a gap and you move over, but your lane is in the process of speeding up and the one you move into is just in the process of speeding down. So you move over, you don't have much gap, and the car slams on the brakes because the car ahead of it started slowing down, because the car has been limited in terms of its ability to make good predictions, and it doesn't want to hit the car ahead. So it errs on the side of braking too much. But whereas if you have a good model that predicts, what is going to happen to your vehicle over the next few seconds in terms of doing the lane merge, and if you have a good model that predicts the actual dynamics of the vehicle in front of you, like how it's going to slow down, you can slow down safely without having to slow down like over safely or over aggressively.
That's a pretty big one. Because that it's a jarring event when you cross into the next lane and you have to decelerate really quickly because the car is braking. So you're saying basically they're predicting, they're better able to predict each lane how they're moving or going to be moving.
Two models are improving. Two models are getting combined and improved that way. One of them is the model of the lead car, the future lead car. Right, your car is predicting what that car is going to do.
So the lead car of the lane you're changing into, basically.
Right.
Okay.
Yeah. So making an estimate of what that vehicle is going to do, and combining that with the estimate of what your vehicle is going to do, and of course the point of that is to give you a better estimate of what the safety space is and how fast it's closing and whatnot. So you can slow safely without having to sort of go over the top in terms of trying to have too much safety margin and brake too hard. So if you use FSD in traffic, where you've got multiple lanes aren't moving very quick and the car needs to make lane changes into lanes that might abruptly stop, like this is, it slams on the brakes a lot.
Yeah.
And it doesn't always have to. And I think that, this is trying to address that problem of if we had better models, we would only slam on the brakes when we really had to.
Got it. A lot of this stuff is actually impressive updates here. Number 16, increased reliance on network predicted acceleration for all moving objects, previously only longitudinally relevant objects.
Yeah. So this implies that they've had neural network they've had the neural networks making these predictions, and they've also had heuristics making these predictions. When they say increased reliance, they're either moving more over to the set of predictions that the neural network is doing, or they're adding additional predictions that the neural network does so that they can stop making those predictions using heuristics. So it's, more of we had this stuff in the planner or this stuff in the perception engine that was being handled heuristically before, and we're moving it over to the neural network.
Got it. And they note acceleration here, but on previous places they noted velocity or lane, angular and lane-centric velocity. So I guess that
was velocity.
Yeah, I guess there's a lot of different things they're improving with detecting objects, moving them more to neural nets. Number 17, updated nearby vehicle assets with visualization indicating when a vehicle has a door open.
Yeah, so prettier pictures of the cars, including more details. Right.
Number 18, improved system frame rate plus 1.8 frames per second by removing 3 legacy neural networks.
Yeah, so this has some interesting implications. So once upon a time, the neural network and the whole system was just synchronized to the camera frame rate. So like all the cameras would grab a frame, you'd run it through the system, and you'd have the next prediction, the next action that you wanted to do. As stuff gets bigger, you have networks that don't need to update as fast, or that you can't update as fast. Like maybe you've decided that you want to make this one network bigger. It'll take more compute time, but you don't need to output as often. So instead of running it on every frame, you collect 3 or 4 frames worth of data, because it might not be it's not necessarily running on camera data. It could be running on the output of some network that you accumulate over a few frames, and then you do an update. So the system frame rate, that's an interesting sort of use of term. There are kind of 2 ways that you could interpret that. One of them would be, how often does the control system update the steering wheel and everything? Because essentially we have processed a whole set of observations through the planning engine into the action engine and decided to update our steering controls, our brake, and that kind of stuff. I think it's probably, that's an interpretation, and that's the simplest, most brute force interpretation. But I think they're more likely to be using system frame rate as how often does our perception system, global update of our understanding of the circumstances update. And I say that because at least up to this point, the perception system has been the lion's share of the computation. And my guess is the downstream stuff they can run as fast as they want to. Like they would be less likely to be frame rate limited by the downstream stuff. You could be wrong about that, because they've started doing stuff like, Monte Carlo simulations of like cars moving around in parking lots and stuff. Maybe they have. That was something that they showed at AI Day. So they might have a more complicated planner in there right now. But up until now, the planner hasn't been as complicated as the perception system has. So I'm guessing the system has been rated. But this also suggests that it didn't improve by a frame. It improved by 1.8 frames per second. So it sounds like the system is running asynchronous right now. One thing that you could take away from this is that, well, why don't they just run it as fast as they want to? So it's possible that they are butting up against the compute limits of the system. Like for all the stuff that they want to put in into a particular build, they can only run it so fast. So some things you have to run slower than ideally you might like to, and there's a trade-off. And that complete set of those trade-offs ends up with a particular system frame rate. So that's one possibility. Another possibility is that there are some inputs that are either noisy enough that you have to sample them over a long enough period of time, or you just get them infrequently enough that it creates a latency in the system. Like you can't really make it your next decision until the sensor updates to the next state and you look at it. But like the fact that it's a small fractional update kind of implies it's more likely to be a compute limit, which is an interesting observation if it's true, because we haven't known that they were compute limited on any significant aspect of what they're doing. And this is compute limited in the sense that they can't put they can't throw the kitchen sink in. They can't just do everything that they might possibly want to do. Also, they took out 3 legacy neural networks. So And we've known for a long time that they do this thing where they add new features in parallel with old features, and then they kind of run them together, which is one aspect of shadow mode. Maybe you could think of it. You know, and you look at how the new system performs relative to the old system, but you keep the old system in there as a backup to be, you know, kind of a confidence enhancing feature for the decisions that you make. But as the new one gets better or proves itself, you can get rid of the old ones. The old ones probably have stuff stacked on top of them that make decisions based on the way that the old system worked. So one of the things that we get from this note is, you know, they continue to have legacy stuff that they're getting rid of, and they're seeing benefits to getting the old cruft out and consolidating on the newer stuff.
Yeah, definitely. Yeah, it's interesting. I mean, throughout this update notes, we notice, or it's easy to see Tesla progressing with this whole neural nets eating the heuristics, you know, becoming a bigger and more important part of the system. And yeah, it's kind of exactly what Andrej Karpathy forecasted.
And I'm interpreting many of these things that way because he said that, and because that's my sense of what has been going on.
Yeah.
You know, it's there. You know, it might be that they're adding all kinds of heuristic functions and they just don't put them in the notes. Like, I don't think that's likely, but it's not ruled out.
Yeah.
So I definitely interpret it as the, you know, more stuff is moving over to the neural network, but the system also is getting bigger, right? Like, it's getting more ambitious over time in terms of the, and, you know, we were talking earlier about how you start with a simple approach to solving a problem, and then you find it doesn't quite work in some corner cases. And so you add complexity to deal with the situations that it doesn't work well. In a neural network, you can just add more training data. You can curate your set and the system will get bigger. Like, maybe you have to increase the size of the neural network a little, but you're generally not adding complexity. That's one of the strengths of doing stuff with neural networks. But in heuristic code, it's more if then for conditionals, you know, it's more interconnection between your code, and, you know, that's not great. If you can avoid it, you don't want the complexity.
So overall, taking a step back, what are your impressions? How impressed are you with the progress of FSD Beta? Just looking at these notes, do you think, you know, it's progressing?
I'll be impressed when I drive it. And the proof is really in the pudding on this stuff. And you know, there are these periods that you go through developing this kind of system where you make a lot of improvements to the system and the performance gets worse. And you're making these improvements to be a foundation for further improvement, for being able to do even better in the future. But, you know, you suffer the pain right now, refactoring the code, simplifying stuff, getting rid of some cruft, improving your process. And you don't see the benefit until a little ways down the road. Like a common, the whole, you know, two steps forward, one step back sort of thing. There's definitely the one step back thing that you, and to really, you know, get a sense of what this means to the driver and what it means to, like, how good the system is progressing. Like, we as users, the most reliable thing we can do is you can get in the car, drive it, and see how it's doing, right? Like, if we were at Tesla's got all these statistics, you know, so they can plot curves of, you know, the frequency of all different kinds of things, and they can see, you know, quantitatively how the system is improving. But outside, you know, aside from the periodic, you know, reduced accident data, which is great, but it's not enough detail to be able to really make good judgments about how the system is improving.
Yeah, definitely. James, it's been fun. Actually, it's like something about going through these technical notes. They're actually very, it's very helpful, actually, just to understand kind of what Tesla is doing behind the scenes. Because in a lot of ways, you know, you could say, oh, Tesla has whatever AI ambitions or AI, you know, capabilities, whatever, but it's so vague, you know, what that means. And to bring it down to the actual things they're doing to make, you know, driving better and their approaches, it just gives, like, it's very enlightening. And and also I contrast it a bit to the whole noise around the stock price and the markets, which is, you know, that's going to be there, you know, up and down. but to kind of refocus just on execution, like how is Tesla executing? What is their approach? Because this is a paramount issue of whether or not they're going to be able to solve, FSD, because this has a lot to do with their future margins, also future products and everything. So yeah, super important stuff.
I don't know if you've, in the last couple of weeks, a number of really shockingly high performance models have been released by OpenAI and DeepMind and Google that, DALL-E is one of them, but there's a whole bunch of them. Flamingo, Chinchilla, they give these models these weird names, but that are using self-supervised data to do stuff that every year in deep learning we get this stuff where people come out with these models and they can do stuff that a year ago everybody swore was, like nobody thought that was going to happen in a year. And they frequently they come in waves. It used to be that the waves would be around, they have these big conferences where, people come out and they show their research and they talk about it and stuff. So you'd see a wave of it around the time there was an important conference. But now we're kind of getting the waves off cycle. Anyway, there have been a number of models just in the last couple of weeks where and we think we're pretty special. There's a lot of tricks that we can do. Andre Karpathy has this, had this photo, which is this famous picture of like Obama stepping on the scale while somebody else is using it. And it's a joke about how Obama's playing this practical joke on this guy and making him feel like he weighs more than he does. Andre put that up and said, that he found it kind of discouraging to think about how far away we were from having a neural network that could explain why that was funny. Think when you think about what it takes to explain that joke, that's an incredible amount of insight and nuance. It's not only got to be able to look at the picture and understand everything that's in the picture from the poses and that kind of stuff, know who the people are, right? But understand what's the significance of somebody weighing themselves, who are these people and what are they doing? And, we're getting there. These language models, they're just getting nuttily good. And, DALL-E, and just today, Google released one. It's called Imagen. And they're models where you just describe something and it makes a picture for you of what you described. And people, people who have access to these models who can freely do whatever they want to with them, they're running all of these implausible things through it because they want to make sure that the thing is actually creating it and it's not just remembering some photo that it was trained on. Yeah. So it's Darth Vader on the cover of Vogue magazine. That was one that somebody did. There's all kinds of these improbable things, and you look at the photos and they're just. It's nuts. It it really is taking these extremely detailed descriptions of a scene and it's interpreting them with a lot of nuance and producing these things. And these capabilities are remarkable advances in the state of the art for these models. And it happened again, right? It's like every year, every 6 months. We get these crazy advancements. And the core technology that's driving those things is the same core technology that's driving FSD forward, right? Like this stuff, it works, it matters, it's moving really, really fast. And it's going to enable us to do all kinds of things that seem impossible today.
With this latest batch of kind of, innovation improvements with neural nets, like what is kind of the key defining or the key thing that's enabling this? Is it just enlarging the neural nets? Is it use of transformers? Is it just better data? Like what is kind of the main factor here?
This latest batch, I would say it's creative use of new techniques that are recently discovered. I mean, the transformer has been an interesting development in the space because it's pretty good at mixing all of this data from different. Originally, they were done as language models. That's what they were developed for. And then somebody discovered that you could just chop up a picture and feed it into it, and it'll work on a picture too, which was a real surprise when it first happened. But then people started saying, like, what if we feed words and pictures in, right? And so they've been playing with this, turning pictures into words, because the original one was like, I'll feed a picture in and get a label out of it. But they thought that that was useful. And nobody thought, oh, I'll feed a label in and it'll make a picture. Turns out that works. Mm-hmm. And it, so it worked a little bit like, 6 or 9 months ago, and then it got better. And now it's shocking. Like you should visit the Google Imagen page. I think it's imagen.googleresearch.com, because you'll look at the photos and they look like photographs. I mean, it's so beyond deepfakes that it's just nuts. And you could potentially inject almost anything and get the machine to instantly generate a photorealistic image of almost anything that you could describe. And people have been doing stuff where there are AIs that make poems, and so they'll have an AI, they'll have it make a poem, and then they'll take that poem and they'll feed it into one of these image things, and it'll make a piece of art to go with the poem that matches it. No, it really works. And I mean, you can imagine these are all prototypes. Researchers, they're fresh out of fresh baked, and they have all kinds of weird quirks that they get. But when they're good, they're amazing, and they get better and better and better at just an incredible rate.
All right, sounds good. Thanks for the update and all that on Tesla FSD, AI Day, your thoughts on Tesla stock. Can't wait to touch bases again and learn more, and this exciting developments going on, I think, all the time. So definitely appreciate it.
Okay, thanks for having me on. It was fun.
Okay, we'll see you, James. Bye.